everyone, how are we doing? We got Lindley in the chat and Gracie and Mackenzie and Christy. Good to see everyone here. We're going to add some new moderators while we're at it. Good to see everyone. Little chill music to get started. Who here has played Kahoot before? We had some really great questions earlier today saying, what is a Kahoot? Has anyone besides me played Kahoot? And maybe we can start explaining because we're going to be playing Kahoot here in just a moment. And we got some prizes. So the prizes are $30 first place, Amazon gift card. And if you want, we could do Starbucks. Tell me who wants Starbucks. 20 second place and $10 third place. Not since high school. Well, welcome back to high school. But we're playing online, even more fun. I'm logging in here as we speak. Evelyn, Mackenzie, great to see you. Let's throw out 100 Mew-Bucks while we're at this. Good to see everyone. We got a bunch of new people here tonight. Evelyn, good to see you. Did I call this Kahoot? Gotta watch out. We might have people randomly join the stream. Let's see. So we actually, if you ever wonder why we have moderators, we have moderators because sometimes we do like this public stream right here. Good to see your Liz. And so with this, sometimes we get a person being like, ooh, you better log in. There we go. Sometimes we get a random person. So we got moderators for that. They're logging in. Could be Kahooting here in a second. So what you need to Kahoot is you need your phone. You need your Kahoot. You need your phone. It's being weird. And with your phone, with your phone, I will send you a code here in a second. That's Batman right there. Didn't see. Batman, where you at? Oh, what? My phone doesn't work. There's Batman. With your phone, you will be playing along with us right here. Let's get the Exam 1 Kahoot. Ooh. New Exam 1 review, Stat 201 2019. Yeah, let's do it. Lauren, great to see you here. Welcome to the chat. 100 points for the chat right there. So I think it's time, everyone. It's time for our Kahoots. Classic mode. You'll see it here in a second. Have your phone out. Have your phone ready. Get ready. We're going over here to Kahoot. Mark, 100 points. Yeah, of course, Mark. Of course, I'm ready from summer mini term. Mark, do you want to join in the Kahoots? Now, if you win, we have to add another prize. Uh-oh, Mark's probably got a huge advantage. Mark's probably got a huge advantage. So what you want to do on your phone is go to kahoot.it. Let me turn off the main music right here. Kahoot.it. And on kahoot.it, you want to enter in the following code. 1927649. And of course, we always listen to our favorite disco music. Kahoot disco music, best Kahoot music there is. Please ask questions tonight while we're doing this. Whoa, we got a bunch of people here. I saw there was like 5 people ready. I like Tick 15. We got 100 people or so. We got 98 people in class. We got Glowing Crab and Joyful Lemur and Winged Bunny. I'm voting for you, Winged Bunny. All the bunnies get the win. Arctic Kitty's pretty cute. Good to see her, William. Amazon Eagle. Prairie Penguin. I'm still learning how to read. Whoa. Whoa. Whoa, just a bunch of people just join in. Never seen it do that. Excited Piranha. Maybe everyone saw the piranha and freaked out. We're going to start here in 2 minutes. Does everyone understand how to log in? You'll go to kahoot.it. It should say it up there. Go to kahoot.it. You go to Kahoot Radiant Buffalo in the chat. Kahoot.it. Please tell me if you're confused on this, or you could also you could use your camera. Has anyone ever tried that? Let me try this. Oh yeah, look at this. If I play, can I win? No, I don't like that. Should Brian play along? No, I don't like that. See, I'm on my last spin of my name. How long does it take to show? Whoa, that is actually instantaneous. So, there you go. I won't play. I don't know. Now we're going to have a person losing. Yes, play. Oh, no, I got to announce. I got to explain the answers. Daniel, great to see you here. Liz, great to see you here. Good to see you here. Matt, awesome to see you. Has anyone used the Discord and gotten help on the Discord? Has anyone asked me a question via... Not a lot of questions have been on the... Maybe it dropped me off because I unclicked it. Has anyone used the Discord and gotten help on the Discord? Like sent a message on the Discord, whether it be a DM or dropped it in the chat. Has anyone done that? Yes, a lot. Yep. Message me on Discord. You can still email me. I don't want people thinking they can't email me. But it's super quick, super quick. It's super, like, you just message and then it's like, boom, boom, boom. Here's this video, like 3 times. Yeah. Well, that's great. I want people to always know it's really quick. We got 30 seconds till we get started here, so get ready. We're about to do some knowledge. We're losing people. I think we lost me, so that's all right. 30 seconds. Discord is easier. It is. That's why I like it, Ashley, is because it's so easy for me to, like, just have a conversation with somebody. So you'll usually see I've got the +9 on my Discord at all times. I like it, though. I like it. It's so much easier than email. With that, Discord's my... and that's awesome. We're getting started. I need some I'm readies in the chat. I need some I'm readies. Remember, if you're in first, second, or third, email me afterwards. Take a screenshot. Never had problems where saying I'm in first and then 10 people tell me they're in first. But I need some I'm readies in the chat. I need some I'm readies. I'm ready. I'm ready. We don't get started until we get those I'm readies. We see Jacob right there, Liz, Jessica, and Leela right there, Sam and Lauren. Everyone's I'm ready in the chat. We're starting here in 3, 2, 1. Time to start. Let's do this. That's why I made it. Okay, first question of the day. Which of the following phrases helps identify quantitative variables? A quantitative variable is something like height, weight. What's your GPA? Now, I said what's your GPA, but watch out. GPA is a weird one. So things like height, weight are quantitative. Now, if you're understanding this question already, think of ways we can display height, weight, GPA, distance moved to campus. These are all quantitative variables. This is understanding your variable types, kind of a good basic starter out. What would it be? It would be how much. Great work. 100 points on that right there. So how much is a quantity? Does that make sense? It's a quantity. When you hear quantitative, think quantity. Does anyone know those graphics we'd use to display one quantitative variables? There's hints on the screen. If someone wanted to display how much students weigh, they would display it in a this. If someone wanted to display how much students, how tall they are, they could display it into this. Now, there's more options. Try to understand what's on the screen right here. Practice and write it. So what do you see right here? What could someone use and display? Height, weight, GPA. Now, just one of those at a time. So what could someone use graphic-wise? What graphics could display someone's height? Histogram. Great job right there. Histogram. You could make it, and there's more options. Like, you could make it in a histogram. That works right there. Dot plot. Gotta love those dot plots. What do we have? Like, is it quote 243 from today? It's either quote 242 or 243. Stem and leaf. That shows you the numbers. Like, you actually see the values. And so, was it quote 242? Dot plot right there. We got all those dot plots in the chat. We'll probably see some more of those graphics coming up. Those are the graphics we could display one quantitative variable with right there. So excellent work. Dot, dot, dot. So we have it. Who's in the lead? In the lead right now is Joyful Lemur. Where's my bunnies at? They'll be on the leaderboard shortly. Next question. Bunnies, don't fail me now. Here we go. Everyone knows I like bunnies. Which of the following phrases helps us identify identifier variables? Now, identifier variables are things that are unique for everything. An identifier variable, finish this sentence if you've already answered. An identifier variable cannot what? An identifier variable cannot what? Since they are unique for everything, they cannot do what? An identifier is a special case. Hint for the test. An identifier, great job, Haley, right there. They cannot repeat. They cannot repeat. They can't stop. They won't stop not repeating. I think that's what Miley said. So you would want which one? It specifies a specific one that cannot repeat. So when we think of identifiers, it might be something like your student ID number, your social security number, maybe your DNA sequence is an identifier. Things like that are identifiers that cannot, will not ever repeat. And an identifier is a blank case categorical variable. Hints for the test, because that's definitely on the Canvas content. An identifier is a blank case categorical variable. So it's kind of a subtype of it. It's like, it's a what case. And remember, I said it a moment ago. Who remembers? An identifier, these are good notes to take while doing this. An identifier, it's special, great job right there. It's like a special kind of categorical variable that can only be, what's up, Devin? So great to see you here. Devin, thank you so much. Kind words right there. Everyone's working really hard. Miss you too, Devin. So good to see you here. I'm just, you know what we're doing? We're throwing everyone here 1,000 points. That's for you, Devin. That's for, we had Mark swing by a moment ago. Mark and Devin here to cheer on Excited Piranha, Agile Chicken, Dazzled Llama, Melodic Fox, Joyful Lemur. So yeah, that's what we do. Stat Nation. That's what we help each other out and we work together and we give each other some positive energy. So we're here for that energy. It's dope. Which of the following graphics can be used for univariate categorical data? Now, I wish I could have put this in, but it would have been a copyright claim from How I Met Your Mother. Marshall Erickson, great gentleman there, said we can make a this of our this chart and a this of our that chart. Maybe I'll show the video here in a second. Huh? Easy way to remember this. We'll try not to get copyright claimed a billion times. Ah, pretty good. Wow. Owen Wilson, your thoughts?
Wow.
He's impressed. So one of the easy... Oh, thank you, Devin. Wishing everyone good luck right there. It's one of my favorite scenes from How I Met Your Mother because I'm a nerd. And so Marshall Erickson right here. I don't think I've ever been copyright claimed on this. It's just 11 seconds. Shout outs to How I Met Your Mother. Check it out. Watch the seasons wherever they're at. Buy the DVDs if you want. Here we go. Marshall Erickson. Explain to us pies and bar charts, please.
This is a pie chart describing my favorite bars. And this is a bar graph describing my favorite pies.
Love his face. That's me. That's me right there. I'm that guy. So why did I literally watch this episode? So what do you know about a pie chart? A pie chart, if you said to someone, what is your favorite bar? You could figure out people's favorite bars from a pie chart and show the percent of like people who like a certain bar. Or if you ask someone their favorite pies, you could figure out the like count of individuals who like a pie. So if I ask you, what is your favorite bar? That's a what kind of question. If I ask you, this is a review of these kind of variable types. If I ask you, what is your favorite bar, which it's this, why is there more answers to his favorite bar? It should be this bar they go to all the time. They're never another bar. What is your favorite bar is categorical. Sam, great job right there. So it's categorical, right? You would have to say like, whoa, turned up the volume for the video. It's categorical where what is your favorite pie is also categorical. So pie charts and bar charts do what? A pie chart and a bar chart, you can see it up here. You see how I've got the arrows on it? A pie chart and a bar chart display the same type of data. Now, if we put that bar chart, if we put that bar chart in order from most to least, it gets a special name. If you put the bar chart in order from most common to least common, it gets a special name. What is the special name we give to a bar chart that has been put in order? A bar chart that has been put in order from most common to least common gets a special name. Pareto, great job right there, Michael. A Pareto plot. So usually I like to say Pareto means put them in order. And it might, so ordinal actually goes to the type of categorical variable where something like steak preference goes from rare to well done. So we might have a bar chart put in order where most people like medium steak, even though it's an ordinal variable. So ordinal goes to kind of the structure of the question, like freshman, sophomore, junior, senior is ordinal. But then if you collect data from students, maybe senior is the most common group, so you'd put that bar first. So even though it's an ordinal variable, we might display it in a Pareto plot showing the most common group to the least common group, even though the groups have a natural structure of an order to them. And that's what ordinal means. Thank you so much. 100 points for the person who mentioned ordinal. Shout outs right there. Reviewing that topic is a lot of help. Let's go over here and see who's winning on the graphic. Joyful Lemur is joyful because they're running away with it right now, but Melodic Fox is right there and Glowing Crab right there. Here we go with the next question. Let's do it. Which of the following graphics can be used to display bivariate categorical? These two graphics are friends. They go out and hang out at the bar together. Watch out because you have all bivariate displays on the screen. Every single display on the screen right now is bivariate. I'd put these on flashcards and understand, maybe even do a little drawing of them. So that way you know when you see it, oh, that's a contingency table. That's a mosaic plot. That's a scatter plot. That's a time plot. So know what these are. I'm going to talk about them all briefly here in a second, but know what they display. We've had some really great answers so far. That's pretty good. I'll take it. I'll take it. Where's my sound effects? Where's my points? That's pretty good answers. A lot of people said scatter plots. That was the wrong answer. That was most common. A scatter plot is used for what kind of data? To make a scatter plot, you need what kind of data? To make a scatter plot, you need what kind of data? You could answer it with 2 letters. So this is color-coded on here, and you want to kind of like cross in on the sections. A scatter plot is what kind of data? Quantitative. Leela, great job right there. Quantitative. And so let's take a look at some scatter plots. Now, it's really cool. 2 seconds, where I'm going to show you some cool stuff. I think it's cool. Okay, so we are going to look at something from one of my upper level classes super briefly. That's an autocorrelation plot. Don't worry about that. No, we don't want the ACF. What is this right here? It's 2 things. We're looking at the month of the year, or like the month on the time, and then we're looking at the employment rate in Australia. So what is this right here? What is this? What is this graphic called? What is this graphic called? And great job, Matt, right there. 2 quantitative variables, bivariate quantitative. So this is a what? It is a time plot. It is a time plot, and it's also a scatter plot. So a time plot is a special case scatter plot where time is on the x-axis. Like this month thing right here means it's a time plot. So, but it's also a scatter plot because all time plots are scatter plots. So a scatter plot more traditionally might look like something like, we'll create something real briefly here, random normal. It's not useful, random normal. If I could do it 10 numbers, and this is just going to be a scatter plot. And scatter plots are easier to remember because they just have the points scattered about. What did I do? What happened? R doesn't like me. Y tilde X. Let's try this again. No, we use jump. I think my brain's overheating. Sometimes that happens. Hey, let's do one of your examples. Here's fat and calories right here. So this is simply going to be, we're predicting fat from calories. And a bonus question right here. What was it called again? Oh, it'll be in the bottom corner here. I'll show you here in a second, Sam. So take a look right here. What could we use to analyze this data? It'd be like that with R. It's like, why isn't that running? What could we use to analyze this data right here? What could we use to analyze this data? So we have 2 quantitative variables. What could we use to analyze this? We have a scatter plot. It's not a time plot because there's not time on the bottom axis. What could we use to analyze this? What ideas are there? Chapter 7 and 8 and 6. Chapter 6, 7, and 8. 2 quantitative variables are the necessary condition to use what tools and techniques? See what chat says. What could we use? Linear regression. Great job right there. Linear regression, fit a line to it. There you go. And that also means we could do correlation. So we could also go over here, and that's under multivariate methods, multivariate, and we could do the correlation between the variables and view the correlation. And we could do the R squared, all these concepts like R squared right here and correlation. Remember, R squared is correlation squared. So if you wanted to double check the mathematics right here, you could take the correlation of 0.9703 and times it by itself and get the R squared value. Jump's carrying a few more values out. I bet we could fix it. We'll check that out here. Daniel, stay at the end. We'll fix up that R problem soon here. But the other graphic we have on the screen, we need to know if we have bivariate categorical data, like we ask students born in TN, and then we say, go to Love, Tennessee. And we're going to put a bunch of yes right here, T for UT. If we had data like this, how would we analyze this data? How would we analyze this data? This is the big question right here. We have 2 categorical variables. Hint, we just did this a moment ago. If we have two categorical variables, how could we look at the relationship between these two categorical variables? A what or what? This is what you were just doing on the Kahoot. We could look at these two categorical variables, a contingency table and a what? Great job. Contingency. So individually bars and pie charts, but together in a bivariate sense, we could see, does somebody love Tennessee based on them being born in Tennessee? And we could see here the bivariate relationship with a mosaic plot and contingency table. So the contingency table is like a frequency table that shows you the bivariate combinations, where a mosaic plot shows you the visualization. And look, people born in Tennessee are more likely to like Tennessee, which that's awesome right there. I want to set the color. We got to do it. We have to do it. It's very important. There we go. People don't like Tennessee. Bad. It's not UT Orange, though. So does that make sense that a mosaic plot and a contingency table both display bivariate categorical data? Mosaic plots and contingency tables both display bivariate categorical data. Let's head back over here to the Kahoot and see who's winning. Lovely Raccoon, good to see you on the leaderboard. It's time for next question. Let's show the code. The code is right there in the chat, 1927649. We'll pause a second here. I think Sam's joining back in. 1927649. Give a 5-second countdown. And it's time to do it. Here we go. Next question is, which of the following graphics can be used for univariate quantitative data? Go ahead. This is big review, so hopefully you've been watching the graphics. I'd take a screenshot of it. There are multiple answers to this question. Univariate quantitative. Now, if I did this correctly, there's only one wrong answer on the screen. Pie charts. Because you can make a pie chart of your favorite bars and a bar chart of your favorite pies. Pies and bars are for what? Put the 3 letters in the chat. Pies and bars are for what? You just want to repeat that. You want to put it on a note card and say, pie charts and bar charts are for this. Pie charts and bar charts are for this. Because you make a pie chart of your favorite bars and a bar chart of your favorite pies for categorical data. Great job right there, Michael. So, oh, you thought I said qualitative. Yeah, quantitative. I usually don't like, so good point right there, Liz. Sorry about that, Liz. I don't like to say qualitative because it sounds like quantitative. I usually say categorical. So you'll hear me say categorical. Now, qualitative is categorical, but I don't like to say qualitative. It's like, it's a category. It's a category. It's for cats. Leaderboard is tight. Oh my gosh, excited piranha. It's going to just jump up here to the top. Dynamic emu. So if you're not winning, don't worry. You're still learning. That's our goal right here, is to learn and to practice. Next question. Find the IQR of the distribution. Now, the IQR stands for the interquartile range. You might have to zoom in a little bit here. I'll zoom in so you can see it. Find the IQR. If you know what you're looking for, you can see the IQR. Probably a hint on the screen, too. So that was a triple hint, maybe. So find the IQR. Sorry, the graphics a little bit small. Kahoot looks to have changed my graphics. The IQR is the what of the box plot. The IQR is the what of the box plot. The IQR is the what of the box plot. Who can fill in that sentence? The IQR is the what. It looks like people got it, so maybe we don't need to review that one too much. The IQR is the what of the box plot. The IQR is the what of the box plot. Oh, and then we'll do an additional question. So when you look for the IQR, it's the what of the box plot. So if you look, you'd be like, where's the IQR? It's Q3 minus Q1. Yep, so that's Q3 right there. That's Q1 down there. And it's the box of the box plot. So it is Q3 minus Q1, the 75th to the 25th. Now, tell me, put it in the chat, be careful. What is the range of this data? This is a common mistake. What is the range of this data? Common mistake on the test. What is the range of this data? So read the box plot here and then tell me what the range of this data is. Sam, you got it right there. Mackenzie, great job. Now, the fences are invisible things that we don't see. Trying to think how many questions we have on the test that do fences. No, don't worry. Daniel, great job right there. Daniel, we're throwing another 100 points. Don't worry. We're here to practice. So the range of the data goes from 0 to 8. Now, fences are invisible. Just a brief talk on fences right here real quick. If we're calculating where the fences are in a data set, it's a little bit of work. Let's get a data set open right here. Let's ask people a question. What question should we ask? Like, let's do a pizza party. I think I'm planning a Mario Kart tournament for the start of the semester, and as long as they let me do it in Haslam, I shouldn't make commitments I haven't found yet. So let's say we're going to order pizza for this tournament here. How many slices of pizza are you going to eat? Put it in the chat right now. How many slices of pizza are you going to eat? We got pizza. How many pizza slices you reserving for this? Tell me right now. This is a quantitative metric. We got here 2 pizza slices, 2, 3, 4, 4. You'd be like, is it Liz Caesars? Was it like Hard Knocks pizza? Of course it's Hard Knocks pizza. Is there any other pizza than Hard Knocks? Shout outs to Hard Knocks. Bet's Pizza Place in Knoxville. Totally believe that. Ooh, this might be an interesting box plot. What is the range of this data right now? Everyone was super serious. What is the range of this data right now? I bet you I could draw this box plot without even, I bet you this box plot. I bet you it looks like the following. I bet you that's what the box plot looks like. Does that make sense? Where's the whiskers on this? Where are the whiskers? Now we'll draw it here in a second, but where are the whiskers and why does it look like this? It doesn't. Don't we usually get like a whisker down here and a whisker up here? Where's our whiskers on it? Where's our whisker? Q3 is the 75th percentile is also the max. Great job, Jessica, right there. So it's still, that's where the maximum is. There's a bunch of people who said 4, and we're kind of estimating because we'll see what it says, but I think this is what it's going to look like. 2 and 4 are the min and the max, and they're also Q1 and Q3. So let's go ahead and draw this right here with graph builder, and then we're going to just drop it right down here and turn it into a box plot. Ooh, it's not. I think we need one more person to say 4. Pretend. Oh, really? Well, there we go. I really thought. I'm so bummed. Now our data looks like this. There wasn't enough 4s right there. 1.5. So now let's think about this right here. We'll add in your thing in a second. So we're looking at this data right here. We'll make it so we can manipulate it over here on the side. Looking at this data and looking at this box plot, be very careful. Where are the whiskers? Where are the whiskers? Mubot is sad too. Mubot is sad?
Why do I sound like this?
This is not good, Brian. Box plot makes me sad.
He didn't look right for a moment there. So with this right here, where are... people are saying the fences are there? So the fences, we don't see. I think that's one of the most confusing things about box plots. We don't see the fences. The fences are where? The fences are 1.5. I got to disappear. They're 1.5 IQRs above Q3 and 1.5 IQRs below Q1. You don't see them because they're a graphical technique. So what is the IQR here? What is the IQR? Oh, the 1.5. Oh my gosh. Liz, 100 points. Great job right there. Yeah, sorry about that. Great answer. So what is the IQR here again? What is the IQR? It's 2. So what's 1.5 IQRs? What is 1.5 IQRs here? So if the IQR is 2, then what is 1.5 IQRs? So think 2 times 1.5. 1.5 IQRs would be 7. Does that make sense? Or 3. It'd be 3. And then we add it to Q3. Does that make sense? Who's following the math right here? The IQR, which is the length of the box, is 2. We times it by 1.5 to get 3. We add 3 to 4 to get 7. And that's where the imaginary fence is that we can't see. Can yes or no, do people follow that in the chat? So that's how we find out where the imaginary fence is. Now we can confirm this and see it visually here if we take probably one of these 3s and manipulate it. If I go to 7, do you see that? Now, there might or might not be data in this range. But as soon as I go to 7.1, it's going to become a what? Because it's outside that imaginary fence. So as soon as I go to 7.1, it'll become a what? Because it's more than 1.5 IQRs above Q3 or more than 1.5 IQRs below Q1, it'll become an outlier. So that's what it's doing. You can't see the imaginary fence right here. That's just where it tells it outliers begin right here. So if there's any data up to there, it'll be part of the whisker. And you can see right here as we increase this or decrease, the whisker just changes, showing us the data goes till there, and it can go up to 7. But once we go beyond 7, we'd have an outlier. Now, it is possible we could have another point right here. So we could have 2 points. There's data up till 7, and then there's also an outlier right here. And if you notice how I changed the data right here. But we could have a gap in our data if it looked like this, where 5 and 7.1, there's no data between that. Do people understand? Oh, can't see the outlier from here. Do people understand this fence concept a little bit better? It's not a big portion of the test, but I hope that lets you know you don't see the fences. They're a graphical technique that are removed once we make the graphic. Yep. It's a little bit, don't worry, I've probably spent an hour telling students about fences, and I'm like, it's maybe like one question on the test. So let's head back over here and do more test questions. Here we go. Oh my gosh, dynamic emu. Whew, that was a dynamic jump. Here we go with the next question. Let's do it. Which distribution has the biggest range? Dun, dun, dun. The answer might shock you. Burger King lettuce. That's the answer. Uh-oh. There's going to be some unhappy people in the chat. Whenever you look for range, look for what? Whenever you're looking at the biggest range, look for what? Whenever you look for range, look for what? Whenever you look for the range, always look for what? Whenever you look for the range, don't worry if you get it wrong. Whenever you look for range, like I said, whenever you look for range, Jessica, you know what? 100 points, Jessica, because here's the thing. When you get to the test, you're going to say, I need to look for these. When you think, because there are questions on the test that say, like, which of these has the biggest range? But when you're going to look for those outliers, you're going to be like, gotta make sure I'm looking for those outliers. So that's really great right here. Don't worry. You miss it here, you get it on the test. That's what we're here to do. So great job. Shout out to those people who missed it. Those dots are small. I'm sorry, it's my fault. Should have zoomed in maybe. Yeah, there's little sneaky outliers right there. You got to check for them. You got to watch for them. They're going to trick you. So yeah, sorry about that. Oh no. Class over. Go home. Oh my gosh. I got problems. No, great work, everybody. And I hope everyone who's having fun. Is anyone here having fun right now? Let's see the leaderboard. But who's having some fun right now? Oh, look, the leaderboard kind of stalled out here a little bit. If you're having fun, we're just pausing here for a second. Put that you're having fun in the chat. Is anyone having fun? I'm having a lot of fun. I am. Ashley's having fun right there. That's awesome, Ashley. We're here to learn. We're here to practice. Not anymore. Don't worry. I honestly couldn't see the graph. I just remember the project. Oh, awesome. Mackenzie, Liz, me right there just said, thank you so much. Don't worry. We're here to have fun. And I try to put questions that I see students miss. I want to be on the leaderboard. Let's make it happen with this next question. Love Kahoot. Here we go with the next question. Let's do it. Trying to. Let's make it happen, Mia. Which of the following is not a way to describe univariate quantitative data? Which of the following is not a way? So these are the ways to describe data. We have words on here that we use. Which of these is not a way to describe univariate quantitative data? So shape is a way. Shape means like unimodal, right skew. I think what else does it have? Outliers. And then we get into some very important topics right here. A lot of people said shape. So when it comes, and let me bring up a Word document right here. When we talk about univariate quantitative data is shape, center, spread. Shape, center. And bivariate data is strength, direction, form, and what's the last one? Strength, direction, form, and what's the last one for bivariate quantitative data? So we're talking about univariate quantitative. And then bivariate quantitative. Kind of. There we go. Jessica's getting right there. That's got enough to get it. Oh my gosh. It's louder in my ears than yours. unusual features, strength, which is kind of outliers. It pretty much is. Strength, direction, form, unusual features for bivariate. So when you think about strength, which this question didn't really go over, strength is like positive, negative, or neither. Direction is positive, negative, or neither. Strength is how tightly clustered the points are around the form. So strength is like strong, weak. Form is either linear or not linear, and unusual features are going to be things like outliers. Now, when it comes to shape, center, spread, shape is when we're talking about things like unimodal, bimodal, right skew, left skew. Does anyone know my saying about the Monster Man? Right to the high, left to the low. What about the Monster Man? Right to the high, left to the low. How do you remember the skew? Right to the high, left to the low side. Right to the high, left to the low. Whatever way the tail goes. Right to the high, left to the low, whatever way the Monster Man's tail goes. So that way you can tell if it's right skewed or left skewed. Now, once we decide if it's skewed or not, that is going to be super important to decide the center. If it's normal, the center would be what? If data is more normal, the center would be what? If data is more normal, more unimodal, symmetric, no big outliers, so we're talking about the shape, it'll be the mean. Great job, Layla, right there. Be the mean. And if it's skewed, it'll be the what? When it's skewed and has outliers, we'll use the what to describe it. Oh, this is good practice right here. The median, exactly. And then think about this. The standard deviation is how many, or the z-score is how many standard deviations something is away from the mean. So standard deviations would go with mean or median. Because think about how z-scores are how many standard deviations something is away from the mean. So standard deviations is something that goes with what? It goes with the mean. So standard deviation is a measure of spread. It's a distance away from the mean. That's a D right there, you can tell. And then the median has the what with it to measure distance. And you can go back to our box plot and think about how the box plot shows the median, but it also shows the what else. The box plot shows the median, which is right here at the center of the box plot, and it also shows the IQR. So it's kind of good to see how these concepts are paired together. And box plots also show you the 5-number summary, so you can see the min, the max, Q1, Q3, and the median. So kind of a quick review of these concepts right here. Univariate quantitative versus bivariate quantitative. And if you're doing bivariate quantitative data, you are making a scatter plot. So scatter plots, chapters 6, 7, 8. Scatter plots. Good work. Good review right there. Leaderboard's going crazy. Remember, we're practicing. We're remembering topics, getting ourselves ready for the test. Here we go with the next question. What is the best measure of center for this distribution? This is now a review question. Best measure of center. If you've already answered the question, put in the chat the only 2 answers. There's only 2 possible answers. If you hear center, you should be debating between 2 answers. If you hear center, you should be debating between this or this. Mean or median, boom. Great job, Jessica. And then how do you pick? If it is skewed and has outliers, which this does, great work. Another 100 points. Because this is skewed, because it has outliers, the mean would be inflated. That is actually the mean right there being pulled towards the skew. So in this instance, the mean is going to be higher than the median. It's going to be kind of unreliable. So we would use the median to describe the center of the distribution and not the mean. So great work, everybody. Great work, Liz and Gabriella. Excellent work. Next question. Let's do this. Or leaderboard. That leaderboard is like everyone. Amazon Wildcat, good to see you on the leaderboard. This leaderboard is just like everyone, these 5 individuals shuffling places. Cooper, good to see you here. Next question. Let's do it. What is the best measure of spread? Now, once again, like the other one, there's only 2 possible answers. Only 2 answers right here. Best measure of spread can only be 2 answers. Spread, I guess there's range, but range is influenced by outliers, so we don't usually like range a lot. Because you can be like, the range of the salaries at the company is like $2 million. Because maybe a CEO makes $2 million and someone else works for free. So we would want a better understanding of the spread. So the spread here is actually going to be the IQR, and a lot of people got it, so I don't review on these ones too much. More people miss it, more review we get. It's the IQR because that's a measure of spread, and this distribution is very, very what with outliers. This is a very, very right something this distribution, so there's such extreme this that the best measure of spread is going to be the IQR, which would be paired with the median as a measure of center. It's very, very what? If distributions are skewed, right there, Jessica. Great work, Jessica. Excellent job. And so if they're skewed, we use median for center and IQR for spread. If they're more normally distributed, like a unimodal bell-shaped curve, we use more mean and standard deviation when there's not outliers or heavy skew. Leaderboard's going crazy. Prairie penguin. How does a penguin get on the prairie? I don't know. We'll find out later. Here we go. Which way is the distribution skewed? Pretty easy question right here. Just same thing. Just seeing if you know it. I can answer the question. Be careful if the axes are a little flipped. This one is not a trick one. Boom. I don't think we need to review that much, but people understand it. Right to the high, left to the low, whatever way that Monster Man's tail goes. That's the Monster Man's tail right there. William, good to see you here. Let's check out the next question. A little lightning round questions right there. Whoo, excited piranha. 11. Wow, is this question 12? Oh my gosh. What is Q3 for the data? I'll zoom in. In 3, 2, 1. Zooming in. What is Q3? I think it shows you on your phone, right? A lot of box plot stuff here. We're going to switch topics I think in a moment. You just have to know how to read that data. There's a histogram below it for quantitative data, number of pets people own. It's interesting to think about this. So I think people are going to get this. Q3 is 2. Great job. When you look at this data, it kind of tells a story. Can someone own an unusually low amount of pets? Yes or no? Can someone own an unusually low amount of pets? You're like, I own this many pets. And someone's like, whoa, that's like a very few amount of pets. Can someone own an unusually low amount of pets? According to the way the data looks. Just think about like the story it's telling right here. Can someone own an unusually low amount of pets? The answer would be, I own 5 pets. Well, you actually, no, the answer is no. Don't worry, 100 points right there. No, because look how there's no outliers down here. So if your friend says, I own 0 pets, you'd be like, okay, thanks for telling me. They're like, sure, people don't own pets. But exactly, because there's no way to go like below that's the min and the 25th%. Like there's a lot of people who don't own 0 pets. Like at least 25% of people don't own pets. That's what Q1 means. But then if your friend says, I own 8 pets, that's very unusual. Not bad. We don't mean unusual bad. We got 2 bunnies. A lot of people don't have bunnies. So only 1 bunny might be unusual. We own 2. Jolly and Morty out there today. So if someone says I own 8 pets, that's an outlier up here because it's beyond the upper fence. We talked about that a little bit earlier. But there's no unusual low amount of pets. There's no like, whoa, you own 0 pets? No way, man. I don't know who we are, but that's some person who's very amused by 0 pets. That's their thoughts on it. So let's continue on here with the next question. Melodic Fox jumping in the lead. Here we go. What are possible options to add to a pivot chart? What are possible options? So when it comes to pivot charts, there's lots we can do. So many options. We could add data tables, which are the labels above it, or data tables, data labels, or data tables. Either one you want. You probably should add a chart title. You should probably add axis titles. All of these are options that you can add. I think people figured it out. You're like, oh, they're all options. Yep. So just trying to make good graphics when you went through the pivot table lecture, just trying to make good, well-composed graphics that people can view, read, and understand. Basically, just being able to read a graphic is the most important thing. So do try to make some awesome graphics. I'd love to go into a whole spiel, but I want to keep everyone focused, right for the test. So let's do the next question right here and look at the leaderboard. Here we are, excited piranha, jumping up there too. Everyone's excited and dynamic and prairie. Next question. Which of the following is a field we can edit in a pivot chart? I've got 2 Kahoots, and I use this one. Current Brian disagrees with 2019 Brian. Not my favorite question on this Kahoot. Yes, all of them. Now, rows and columns subdivided. Filters out data. And values is probably the most important one because the value is what you're displaying. The value is the actual thing you're showing in a pivot chart. So when you make a pivot chart, you want to put what you're displaying and then decide how to subdivide it by rows and columns to split it apart. So I think I like this because, like, if we're doing a pivot chart lecture, sometimes I'll do this right here and show you how to do it. But we're going to focus on the test questions tonight. So let's continue on. I think that's the last pivot one. Pass, Brian. You better not put more pivot on here. Let's find out the next question. Great job, Melodic Fox. Here we go. Question is, on the standard normal curve, what percent of area is above positive 2? Love it. So you've kind of got a little drawing right there, but think about what percent of area is above positive 2. I'll be drawing this out here in a second. But if you know this, you know it quickly. I'll be showing how to solve this answer here in a second. This is a tougher question, but do you know it? Wow. How did you get that? I am so proud. We're doing another 1,000 points. I don't care. Sometimes I go a little crazy during these Kahoots. I'll tell you when I'm shocked. Like, I didn't expect the answers to be that quick. Didn't expect that many people to get it. That was about like 90% of people getting it. So when you hear 2, what do you think of on the normal curve? If I say 2 is a z-score, z-scores are the standard normal curve. If I say 2, what number pops in your head? Like, if you've been practicing the empirical rule and you know 68, 99.7, it's also on here later. If I say that, what pops in your head when you hear 2? If you hear 2, you hear 95. Great job, Lauren. More points, Lauren, right there. So you hear 95. So 95 means 95% of observations. How would you feel if this was test scores? I told you, hey, guess what? The test came back normally distributed with a mean of 90 and a standard deviation of 2. How would you feel about this? I mean, it's kind of a small standard deviation, but how would you feel? Like, I don't tell you what you made, but I say it was really normally distributed with a mean of 90 and a standard deviation of 2. The 2 means the variation. Why? And then, so think about that's a great answer right there. I'd be like, that's pretty good. And then I'd be like, darn, I really wanted to get that 100. So why would you feel pretty good, especially with this boundary right here? Why would you feel pretty good? Why would you feel pretty good about this? If I tell you it's normally distributed with a mean of 90, well, you might make a 90. So this is the middle 95%. The middle 95% of students scored between a what and what? The middle, like, 95% of students. Great job, Jessica, right there. More great answers. Yep. Yep. So, I mean, like, unless you're an extreme outlier, it's virtually impossible you made below like a B, right? Like, you'd have to be, to make a B, which is in the 70s, you'd have to have a z-score more extreme than what? So think about this question. To make a C, you would have to have a z-score, and think about how 2 is the standard deviation, then think about 90 going down to in the 70s, not a 70, but like 79.999999999. You'd have to have a z-score that's below what to score below a B? What would you, to like make below an 80, your z-score would have to be lower than what, which is pretty far away. So negative 10 would put you at a 70. So think about this. A standard deviation is 2, right? So if a standard deviation is 2 and you keep going down, you'll get 82 down here, and then you'll get 80. Does that make sense? So if you had a z-score of negative 5, that means you're 5 standard deviations below the mean. And so z-scores can also be decimals. So anything below negative 5 would be something that's below a B. So negative 6 would also be a C. Someone who said, they're really sad, they say, I was an outlier. My z-score was negative 6. Now, before finding me what value this is, tell me what this means. They're saying to you, I did what? My score was this to the what? my score, they are a -6 z-score. They're really sad. They're like, man, I was an outlier. I didn't fail the test, but I got a z-score of -6. They're saying they're not direct test questions, but I mean, they're pretty similar. There's 6 standard deviations below the mean. Below the mean. Exactly. Good job, Matt, right there. So what did they score? So you go to the mean and you say 90, 88, 86, 84, 82, 80, and they scored a what? 78. So you could actually take, even I have to think about the formula, you would take the mean. We don't want to do that in highlighter. You would take the mean, and then you would add, we would add it, but it's a negative, subtract 6, and then the standard deviation right here. So that's the z-score, and this would get the observation y. So more specifically, we would plug the z-score in. So I'll write the equation right here. I don't usually do it by hand. I try to think it through theoretically. But their observation of 72 is equal to the mean of 90 minus 6, which is their z-score, times the standard deviation of 2. So that's 90 minus 12. Does that make sense? And great job, Matt, right there. So, oh my gosh. 100 points. Brian made an error. 78. We were saying 78, and I think I was thinking the 12 or something. But 78 is their observation. Y being the observation, mu being the mean, z being how many standard deviations they are below the mean or above. It's the distance above or below. The exam up to chapter 8, correct. Good question right there, Liz. Good question. And then 2 being the standard deviations right there. And everything, it is posted to Canvas. So if you're looking for the review material, make sure to go to Canvas. So make sure to go to Canvas. Has anyone gone to the review material on Canvas? Make sure to go to that. So I have specific review material on Canvas. And thank you so much. I really didn't get any complaints about this weekend. I am so grateful. I was just waiting for people to be like, what in the world? And then they're like, ah. And I was just like, I was ready for wait, what? There's a lot of videos. What do you... I don't like Canvas. I say, publish this. It's also posted to the Satuan website, but it is through Chapter 8. Thank you, Jessica. Yeah, and hopefully my goal was to communicate to everybody and then make exceptions and changes to kind of fix scenarios. So we roll with the punches here. We roll with the punches. We'll fix that here a little bit. Ma Pearson. And the area above 2, just in case anyone's wondering how we got that value, if 95% is inside of here, what is total outside? What is total outside? If 95% is total outside, there's the secret one, Sam. If 95% is total inside, what is outside? 5% total. And that makes this and this equal to 2.5 remainder. So everyone got that pretty quickly. So I kind of did an extended problem on this right here where we did more of a different question, and good work. Great job, everybody. So good stuff right there. That was the next question. Here we go. On the standard normal curve, what percent of area is below -1? Ooh, tougher one. Below -1. This is a tougher one. Rapid fire question. Below -1. Even my brain had to think for a moment. Now, what's really good is if you draw this, if you draw on it, you can kind of guess the answer. If you draw on it, you can kind of guess the answer. Does that help show the answer? Like, what percent of this curve have I shaded in now? So without even the knowledge, if you draw on it, I mean, you got to have some knowledge. Does that help show that I've shaded 84% of the curve below +1? 84% of the curve. And then we'll show how to get it. Did we do? Ooh, we caught some people. So don't worry if you got it wrong. But questions like that, always we say, draw it out. That's what Joey said in Full House, I think. Draw it out. So let's go back here to a normal curve and talk about it. When you hear 1, what do you think on a normal curve? If you hear 1, what do you think on a normal curve? What area jumps into your mind? If you hear 1 on the normal curve, you think what area with the empirical rule? This is like test questions. You might get pictures. Cut it out. Cut it out. I thought you said draw it out. That's what I heard. It's one of those Mandela effects. So 68%'s in the middle. And then what percent? So this one said positive one. It did, right? Let's double check. Below positive one, below positive one, below positive one. Did I say negative one? The answer wouldn't be on the screen for that. Very sorry. I'm very sorry about that. I might have ruined someone's streak. I'm gonna throw 1,000 points apology. I don't mean to get out that many points, but I really do apologize for that. Sorry about that. I don't know why I said that. Error on my part on that one. The answer wouldn't be on the screen for that. Does anyone know what area would be below -1? Drop it in the chat right now. What area would be below -1? We'll show that here in a second too. But see if you can find that one. So that answer is not on the screen. You're here for the points. Nice job. It'd be 16%. That is correct. And so it would be 16, which luckily is not on the screen. So I'd hope that maybe, I'm really sorry about that. Misspoke. It happens. So if you heard -1, you would be down here. And it'd be this. Now, why is that 16? Why is that 16? That is 16 because if 68 is inside, then outside is what? If 68 is inside, then what is outside? If 68 is inside, then what is outside? So if you're like 68% of the area is in here, boom, Jessica's getting it right there. Nice job. And that makes this 16, and that makes this 16. So what is, tell me mathematically what this is first. And there's a few ways to get it. I'll draw it the other way, like this right here. There's two mathematical ways to get this, which I would suggest doing. I'll draw the other way like that. So what are the two mathematical ways to get this? Like the area below this point is what we want. We want the area below here. So there's two math ways to get this. Two ways to get this answer. There's probably more than two. 68 plus 16, yep. That's one right there. Or 100 minus 16. Great job, Mackenzie. So you could just subtract out 100 minus 16 and get that right there. So subtracting off of the total curve is another way. Good work. Good practice. There are empirical rule questions on the test. And I think it's a great way to get a good score. What's going to happen to the leaderboard? Oh, my God. Let's do this. Let's throw an extra fourth place. 30, 20, 10, and 10. Okay, so there we go. There's 30, 20, 10, 10. That's like 40-ish questions, 40 or so questions on the test. They're usually about 40. So if you come in first through fourth, we threw an extra prize on there. Let's continue on as you wins. Remember, Amazon gift card or Starbucks. Tell me in the email and tell me what email you want it sent to. Here we go. Question 17. What percent of students are expected to make above a 60? So 60 is right here on the curve. Brian, you better not have made errors on this. What percent of students are expected to make above a 60? Now, there's something really interesting about this question. Because if you look at what we just did, there's something really interesting. Does anyone notice it? Does anyone notice what is interesting? Michelle, thank you. Oh my gosh. I'm sorry. I want to apologize, everyone. I've been going since morning office hours. I've been going since then. Probably need more coffee. Coffee. So after this I'm gonna go eat some dinner. I'm sorry. Little bright light. It's funny, there's these lights right here. Woo! Oh, you can see us. Watch this. It's a bad idea. There's lights. There's the lights. The bright lights. Yeah. Coffee is what I run on. Yes. It's still interesting about this. What is interesting about this? Because that value is what? So let's break down the question. You ready? The question is what? Thank you, everybody. Brian, brain melt. The question where we had a 70 and we had a 60 here, 60 is where on the curve? 60 is where on the curve? 60 is where on the curve? So if we have a normal curve with a mean of 70, a standard deviation of 10, 60 is a standard deviation of what? Or a z-score of what, I should say? -1. So it's the graphic we just drew, and we're just finding this area right here, which is 16%. Does that make sense? A lot of people look to get it right there. So it's going to be 16% because it's one standard deviation below the mean. And just kind of communicating that to someone that they are one standard deviation below the mean. Excellent work. Brian's going to slow down reading the questions right here. You ready? We're going to read it very slowly. The leaderboard's just jumping all around. Here we go with the next question, reading it slowly. What percent of students are expected to make above a 55? Now, I like this because it's like a My Pearson question, but also you have to kind of use your knowledge on how to solve this. Now, be careful. It's a little tricky. What percent of students are expected to make above a 55? A little small right there. 70 with a standard deviation of 10. Tricky. What should you do first? What should you do first? I think you can narrow this down pretty quickly. What's Joey tell you to do? What should you do first? A lot of people are wondering. Has anyone gotten it? This is a tougher one. The answer. Nice job. So if we draw this out right here, let's look at this. So here's it right here, but let's think about this. This is not showing us the area above a 55. Let's take a screenshot of it and bring it over to the other screen. Let's think about this. If on Canvas, or on your My Pearson, oh my gosh, on your test, it told you, and this is how the test questions work. Are you ready? This is like an actual Chapter 5 test question. It said something like, a test is normally distributed with a mean of 70 and a standard deviation of 10. Below, we see that 6% of students scored above a 85. What percent of students are expected to score above a 55? Now, the first thing I would do when I see a question like this is I would turn 85 and 55 into what's? The first thing I would do is I would turn 85 and 55 into what? Who knows how I would handle this? I would turn 85 and 55 into what? What would standardize those numbers? Pretty evenly split. Pretty evenly split. Great job, Matt, right there. And Mackenzie, I'd turn them into z-scores. Does anyone know the z-score for 85? What is the z-score for 85? Now, you can find it or you can kind of see it visually. So to find the z-score, we would go observation of 85 minus mean of 70 over the standard deviation of 10, which is observation minus mean over standard deviation to get a z-score. So the z-score is 1.5 because it's 1.5 standard deviations above the mean. Does that make sense to everybody right there? It's 1.5 standard deviations above the mean. So this is a z-score right here of 1.5. And what do you notice the z-score is down here for 55? 55 has a z-score of what? And slow me down if you have questions. This is a tougher one. Of negative 1.5. Great job, Mackenzie, right there, of negative 1.5. So think about this. If the z-score down here is negative 1.5, and you could do the same math, it's just that you're going to plug in 55 here instead of 85 and get that it's negative 15 divided by 10. If we were to have up here on this side 6%, then what is the area in yellow? What would that area in yellow be? If the area over here is 6%, then the area in yellow is 6%, because the curve is what? The curve is symmetric. So if the area up here is 6%, then the area down there is 6%. So let's ignore, now that we know this is 6% over here, let's ignore this area over on the other side and think about the following. If there's 6% on the low side, how much is above it? If there's 6% on the low side, how much would be above it? So if there's 6% down there, how much would be above it? 94. Exactly. So the remaining portion on the other side. Now, this question asked it a little bit differently. The way it's intended to be solved, I kind of decided to make this, because a lot of people ask, like, well, how would this look on the test? Great question to ask. So I kind of formulated a really good kind of like how things look on the test, where you have to use your knowledge to then solve it. If you've been doing the Canvas contents, this looks a lot like a Canvas content, and this is the information you'd be provided. The intended solve for this question is a little bit different, at least with the Kahoot question. So when you think about this right here, we're asking about this spot right here, right? Let's think about two spots. How much area is above here? As in, if you went to this red line and you shaded everything to the right, how much area would this be? Who knows that? If you went to that red line and you shaded everything to the right of it, 84. Why is it 84? And we'll draw that out here briefly. It's 84 because 68% would be in here, leaving 16% on either side, and that would mean 84. Now we need to do one more arrow, and we would go right here, and how much area would be total under this blue arrow? There we go. How much area would be total under that blue arrow is if we shaded from the blue line over. Close, not 95, close, 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 close. Close to 95, close to 95. It would be it would be 97.5. So it has to be between these numbers. It has to be between 84 and 97.5. And look at this number right here. What do you notice about this number? So our answer has to be between, let's show it again. Our answer for what the area is between or from the black line over has to be less than 97.5 and more than 84%. Does that make sense? And the 99.7 is 3 standard deviations. This is probably one of the toughest problems on this Kahoot, I'd say. Do people who thinks they understand this solve? It's okay if you don't. Do people understand it? This is how it could be solved using the empirical rule. And then we did a version of it, solving it using kind of Canvas, or if we gave you the numbers to use. This is a tough question. So if you don't get this one, not the end of the world. It's one of those ones that you get to on the stage, you're like, oh, it's one of those really tough questions. But if you got it, great work. Let's continue on to the next question. They can be multiple choice. They can be numeric entry, different things. Sometimes, could you go over one of the cameras? Yeah, let's do that. I think we'll do one of those. Tell me which one, Leila, and we'll do it right here. We'll put it at the end of the video. Next question. Here we go. Write the regression model. Ooh. So what do we have right here? Lot to read. We need to write the regression model. Well, a regression model uses B0 plus B1x. B0 plus B1x. B0 is the intercept. B0 plus B1x. We need to look at this output right here. We have to say, where's the intercept? There's the intercept. Plus B1. B1 is the coefficient of the slope. There's B1. And there's the x variable. Tough question. The answer is... Wow. Nice job. Well, we lost some people. That makes me sad. We're in some tougher material. We lost some people. Any questions about this? When you look at a regression output right here, we have to know what we're seeing. Regression has two estimates, an estimate of a what and an estimate of a what. Regression has two estimates. It has an estimate of a what and a what for a line. To make a line, we need to have an estimate of the this and an estimate of the this. And then we also have a name for this. We need to have an estimate of the what and the what. The B0 and the B1. So this is B0, which is the intercept. And then we also have an estimate of the slope coefficient right here. That might not be visually perfect, but B0, Jacob, great job right there. Jacob will make it mod, and Laura will make it mod too. B0 is the intercept estimate, and B1 is the slope coefficient estimate. A great way to remember B0 is it's when x is equal to 0, because you'd be on the x variable axis right here, and you'd have when x is equal to 0. B1 is for each 1 unit increase in x. So it's kind of that rise over run right there. And that's associated with the x variable. So when you plug it into an equation, you'll see that you have the y variable of interest is equal to B0, which is the estimate of the intercept, plus B1 times the slope variable, which is the coefficient of the slope. Next question. Here we go. Leaderboard going a little bit crazy. Headed up. Great news. Awesome. See you later, Ashley. Here we go with the next question. Let's do it. Which of the following is not a word or phrase to describe correlation? When it comes to correlation, which of these is not a word we use to describe correlation? So if you go back to univariate data, we have shape, center, spread. Bivariate data is going to be when we make a scatter plot, and that's when we use correlation. Throw some teaching to the test moments here in a second. Oh no, Sam, that's all right. A lot of people said unusual features. Unusual features are just another name generally for what when it comes to bivariate quantitative. Unusual features is basically what's for them. Unusual features is basically a what? Outlier. Great job, Mackenzie, right there, and Mia. So what are the possible values of correlation? Correlation can go as low as this or as high as this. Correlation can go as low or as high as this. So correlation has possible values. Correlation can go as low, well, correlation values. It is from -1 to 1. Great job right there, inclusive of those values. Let's say this. If correlation is 0, there is no association. Go ahead and click yes or no in the buttons in the chat. If correlation is 0, there is no association. Yes or no? What people say. If correlation is 0, there is no association. Good job. The answer is no. If correlation is 0, if correlation is 0, there is no blank association. If correlation is 0, there is no blank association. So there might be an association, but it wouldn't be this. Hold on, 50-50. No linear. Correlation measures the linear relationship. So this is a true statement right here. This is the truth. And you see right here, there is an association, but it's not linear. So the correlation of this would probably be close to 0. So there is not a correlation right here. There's not really a strong linear relationship. Correlation only measures the linear relationship between X and Y. Great job right there, Sam, Leila, Met, Jessica, and Jacob right there. Excellent work. So correlation's meant to measure linear relationships between a quantitative X variable and a quantitative Y variable. 19 votes. I like that right there. Next question. Amazon Wildcat. Oh gosh, this is getting scary in here. Here we go with the next question. Interpret R squared in context of the problem. Love it. What is R squared? R squared is the percent of variation in Y explained by the variation in X. So which of these is R squared? Well, we have to look at the output on here and think about it. Now you have to be careful because you don't square root R squared. That looks to me like correlation maybe if they've square rooted it. So now we take this and we want to talk about the X and Y relationship. So it's blank percent of the variation in Y is explained by the variation in X. So 94%, great job. 94% of the variation in weekly hours reads explained by the variation in age. Try for a moment to find me correlation right here, and how would you find it? To find correlation from r squared, do what? And then let's throw a trick question on here next. To find correlation from r squared, do what? So find me correlation from r squared. Now remember, r is correlation, r squared is r squared. So if the r squared there is something like 96%, there's a bit of a problem though. You square root it, right? But there's a bit of an issue, and do know this, because what if, find me the correlation now, because there's a bit of an issue. Find me the correlation. This is one of those teaching to the test moments. Teaching to the test moment. We got it fixed up. There we go. Find me correlation now. Boom, Met got it right there. Also check the sign. So what would be the value right here of correlation? Met is correct. If you are taking and getting correlation from r squared, you square root it and then check the sign. Checking the sign means look at the plot right here and see if it goes up or down. And so what is the correlation right here? Well, it is negative. Great job, Mackenzie, right there. It is negative. So, but what is it? What is the value of correlation? Like if this is your test question, it says enter in the value of correlation. I think, yes. Oh, Liz got the answer. Great job, Liz, right there. Yep. And great job, Met, right there. That looks to be the answer. So you would take this right here, and great job, everyone, practicing. And then you would square root, and then you just go negative right there, and there's the answer right there. So that would be the answer, the negative of the square root of 0.96, because correlation acknowledges direction of a plot. Strength, direction, from unusual features. That's a very strong negative linear correlation with no extreme outliers. Okay, next question. Here we go. Good to see you here, William. Throw William some points. Melodic Fox still in the lead, but Soaring Yak. Who knows what's going to happen? Explain the slope in context. So slope is what? Slope is for each 1 unit increase in x, we expect y to increase by b1. So you have to say for each 1 unit what? What is the x? For each 1 unit increase in x, which is age, so for each additional year, I expect weekly hours reading to increase by what? And it's going to be over here. Oh. So slope is for each 1 unit increase in x, we expect y to increase by b1. Got some pretty good output for that right here. So you can see right here, the slope is associated with the x variable. Does that make sense to everybody? The slope is associated with the x variable. So we're predicting right here how much somebody texts, let's say, during the week. And so for each additional weekend text somebody has, I expect them to have an additional 1.5 weekday text, if we're predicting weekday text right here. So for each 1 unit increase in x, so this is the x variable right here, and that's the name of the x, we expect y, which is the variable we're predicting, to increase by b1 on average. So good stuff right there. Let's continue on. Oh, show problem. Ooh, it's a close leaderboard. I have no idea who's going to win. Please make sure to email if you win. Or I guess email me is going to be best. Send me an email, even though I Discord a ton. Send me an email. Probably Discord might work too. We Discord all the time. Next question. 5 more. Explain the intercept. Now, the intercept is when? What variable is equal to 0? Type 1 letter in the chat. So you got to find that variable in the equation. When what variable is equal to 0? The intercept is when what variable is equal to 0? The intercept is when what variable is equal to 0? The y-intercept is when what variable? The y is equal to 0? That is equal to 0. The x, Layla, great job right there. The x, so when someone's age is equal to 0, we expect weekly hour reading to be negative 1.68. Now, what's so weird about this? Do you think if we talk to college students, we have people whose ages are equal to 0? This is a good time to mention a key term right here, is if we talk to college students and we predict how much people read, do you think we'd have somebody's age equal to 0? No. So predicting for somebody whose age is equal to 0 would be a what of the model. If we made a prediction here at the intercept, we'd be whatting our model from the data, key term to know. So here's kind of the bounds of our data, and anything we make for predictions on our model outside the bounds of the data is known as a what. So this is when you're outside your X variable of interest and you don't have data. Not really an outlier. Outliers are points that are far away. Good guess, Mackenzie, 100 points. Extrapolation. So I like to say this is extrapolation because it's on the X variable. Extrapolation. So that is an extrapolation of the model because the model doesn't have data in that area to make predictions. So sometimes it makes really wacky predictions because there's nothing down there to even tell it what it should be predicting. So when we say we'd expect individuals who are 0 years old to read negative 165 hours, well, the model doesn't even make predictions down there. So it's not really meant for those purposes. So that is an extrapolation, and that's when you predict far outside or anywhere outside of your X bounds. It wouldn't be an extreme extrapolation to predict down here, but at the point when we're at 0, that's a pretty far extrapolation. It is a matter of degree, but anything outside the X bounds is extrapolation by definition. Sometimes you just extrapolate a little. Next question. That's what we do in time series. Here we go with the next question. Let's do it. Which one is not a condition for regression? Oh, I love this one. I hope. Don't fail me now. Regression has 4 conditions. Does anyone know the one condition not mentioned on here? Regression has 4 conditions. Correlation has 3. Who knows the condition not on this screen for 100 points? Regression has 4 conditions. Plot doesn't thicken. Great job right there. The plot doesn't thicken. Yeah, great job, Sam. So large enough is a condition we'll do later on in the later on test 3. Large enough is not an answer. We have QQ straight enough, no outliers. Let's bring it over here and talk about it for a moment. QQ straight enough, no outliers. Plot doesn't thicken. Okay. So this is not one of the answers. It should be plot not thicken. So the idea of QQ, which I call it QQ a lot of times, is 2 quantitative variables. That means you're doing something like, and we'll do it in color coding, that means you're doing something like height and weight. And if you have height and weight, you're making a what plot. So if you have height and weight, which are 2 quantitative variables, you're making a what plot. So if you have height and weight, you're making a what plot because it's 2 quantitative variables. So by having 2 quantitative variables, you have a what plot right here? A scatter plot. Yep. So here we are with our scatter plot. And rather we should, well, I guess we could do it this way. There's the scatter plot from 2 quantitative variables. And the relationship here is straight enough. Straight enough means that a line goes through it pretty well. So now we have straight enough. No outliers means we don't have outliers. So we don't, I'm showing that they're not there. So that means we do not have outliers. Mods, this is where we hide user on channel. There you go. That's how we deal with it right there. So I think if you see that, we got it right there. There we go. That's the YouTube for you. So if you don't want to be a mod, if you don't want to see stuff like that, let me know. But that's why we have mods, the YouTube thing. So with this right here, the last one, plot doesn't thicken, means the model generally stays what throughout. The plot doesn't thicken. The plot doesn't thicken. What does this mean here when we say the plot doesn't thicken? It generally stays what? Thank you, Michelle. Michelle, 100 points, even quicker than me right there. I think we've deleted and hidden them. Plot doesn't thicken means what? Plot doesn't thicken means what? It means that it stays about what throughout? What does that mean? So much silence. And I'm going to do something. Let me go over. I'm going to put a delay on just in case we're getting bots in here. So we can go a little bit longer. We haven't had a bot in a long time. Should be right here. Slow mode. 10-second slow mode. That should update now. Is everyone still here? Anyone? Maybe I lost the chat. I think the chat's going and I just can't see it. 2 seconds. Let me reload chat. Okay. 2 seconds, everybody. Okay. 25 watching. There we go. My chat froze. Chat froze. Craziness. We're back. Good to go. Put slow mode on. I should probably enable that for the rest of my streams always ever. Thank you so much, everybody. Sam. You crazy. Sam, 100 points cracking us up. Okay. Yeah, people are messaging. I don't know what happened. Chat paused for me. I think my brain overheated. So with this right here, we can see that it's about the same width throughout. It's going to have the same thickness. That's what plot doesn't thicken means. And if we have something that doesn't follow the plot doesn't thicken, then we'd have a model that looks like this. Now you have to watch out because I've had people tell me that this is fine. I'll do the one that people say, oh, but it's fine because on this model, the plot is getting water. And I think, Matt, we were talking about this one. The plot gets water right here. The plot is getting water in this. The plot is getting water in this right here. We can hide user on channel. The plot is getting water in this one right here. The plotter is getting, and Mubot is even, oh man, Mubot is, are we going to have to hide Mubot? Because he's saying the name. Mubot also acts on things like that. Yeah. Poor Mubot. Yeah, just, Mubot is doing it too. Where's hide users? Where Mubot, you have to go away. Mubot, you have to go away. 2 seconds. We're doing a little maintenance right here. Mubot, you have to go away for a little bit. His last words were, I am Mubot. His last words for a little bit. Doing mod you, Mubot. All right. 2 seconds. We're doing maintenance. I might have to remove where he goes after symbols because I don't want him saying the... I need to change his report message on somebody. 2 seconds. No, he should just remove it. He's supposed to remove it, but he warns a user if someone does that. We'll fix that. Oh my gosh. Gotta love the bots. Gotta love the bots. Happens on the internet. Okay. Who wants to bring that energy back? Bring me that energy right now. Let's do it. Who's got that energy in the chat right now? Who has energy? Mubot's last name. Who has that energy right now? Show me that energy. The Okona Groot saying I am Groot when he got vaporized. It's so sad. It's so sad. Thank you for that energy. Let's hop over here. That is so sad. He's like, I am Mubot, and then he just goes away. He just vanishes.
I am Mubot.
He's gone. He's gone for now. Sad day. Is the following a good residual plot? Is the following a good residual plot? Of good residual plot should show nothing. Nothing at all. Literally the bots leave and Mubot, we gotta turn off Mubot. A good residual plot shows nothing at all. Nothing at all. And the answer is, this is a very good residual plot because it shows nothing at all. It shows nothing at all. That's a good residual plot right there. A good residual plot shows no patterns. It actually looks completely what? Say everyone's favorite word. Mubot's not going to be here to cheer us on with this, but say everyone's favorite word. A good residual plot looks what? A good residual plot looks what? What does a good residual plot look like? A good residual plot looks random. And that's what we want to see right there is just a random pattern. Now, a residual plot is what's left over after your regression. So this is not a regression plot. The way to make a residual plot is to take your model right here and make the line what? Take your model and make the line what? To turn this into a residual plot, we take the model and we make it what? To turn it into a residual plot. Thank you. And we can hide them on channel too. So if you go to, there's like, great job, people are doing it. I did it first, maybe. We make it flat. First time it's happened in a long time. Somehow I just had this feeling. We make it flat. So by making it flat, we can now see if things are above or below. And this is going to be the residual plot for our model right here. Continue on to the next question. We've had so many streams. We've gone like a year and a half, and it's all catching up to us today. Next question, but we got to say a sad goodbye to Mubot. I'd play that song like Until I See You Again or something if I could, if I wouldn't get copyright claimed on it with Mubot. Like, and like make a montage to him disappearing. Next question, here we go. Almost done. What percent of track runners are expected to run a time of 290 or higher? 290 or higher. Adam, good to see you. It's been a crazy night, Adam. 290 or higher, what's the first thing you notice about 290? 290 has a z-score of what? 290 has a z-score of what? (290) has a z-score of what? -2. Great job, Liz, right there. Jessica and Lauren, great job. And people got it. This is using our knowledge of the 68, 95, 99.7 rule, where we graph the area between and find 95% is between here and here. So if we want the area above a z-score of -2, it's going to be 97. So one of my best advices for this test is going to be to draw it out and keep your drawings, because if you're drawing during the test, now you can't bring notes to the test. Thank you, Adam. Mods have had an interesting night tonight. Interesting night with the mods, like the help. Thank you, mods. So the area above a z-score of -2 is going to be 97.5%. That is the area above, because even though we use different numbers right here, this is still a z-score of -2. And for this question also, it's still a z-score of -2 when we say 290. There's a fun question at the end right here, which I think only has right answers. We're on 2 more questions, but the last question is a fun one because we got to have some fun. Leaderboard's bouncing around. Here we go with the second to last, or the last real question. Here we go. 68, 95. You got to know these numbers. Easy question right here. Rajab, good to see you here. 68, 95. I'm going to turn Mubot back on and try to fix it. I still want to use the gift card I won. I've started after a year. Oh my gosh, Mubot crashed in the universe. Oh yeah, make sure to use it. At the end of the year, I go back and do the full previous year. And I've started to, there's like a 1-year thing. Try to use it within a year. Because I probably give out easily a couple $100 in gift cards. Like each year I give out a good bit. 68, 95, 99.7. I'm going to fix Mubot here in 2 seconds. It's his moderating. He needs to be fixed on Mubot. Where's his mod? I might fix this here in a second. We'll do the last question right here. Well, no, we need to announce the leaderboard. I don't want to be doing this while we announce the leaderboard. Where is his modding? Mod tools. Here we go. Symbol protection. Okay, here goes. He says username. We're going to remove out his ability to say usernames now, because I don't... If someone gets in trouble, they'll know. Okay, so he is now fixed. Okay, so Mubot should be fixed. He got snapped back. Oh man, we could bring him back. We could bring Mubot back. We could bring him back.
I am Mubot. Hey, I'm back. There we go. All's right with the world. Sorry about that, Brian. I didn't mean to write those names, but you programmed me to. It's your fault, Brian.
You're so mean to me, Mubot. Why are you... I'm sorry. I'll do better. I'll do better, Mubot. Okay, you're programmed correctly now. We fixed your programming. Everything should be good. Everything's right with the world. It is Wacky Wednesdays after all. We'll finish off the Kahoot here. Having some... He died. Give him a break. It's Wacky Wednesdays. Don't blame the bot, blame the program. That's the way it goes. Let's go here to the main screen and fish the Kahoot. Let's do this. Oh, Mewbot, you're fixed. You're good to go. Here we go with the next question. A fun question, which I think only has right answers. So be quick in answering. So hint, fun question with only right answers, I think. Pass Brian, don't fail me now. Here we go. Best superhero ever.
It's me, Tiny Brian, here to announce the winners. I always announce the winners. Ooh, I like Batman. Spider-Man's cool too. Gal Gadot, she's a good Wonder Woman. She did great. Iron Man, Robert Downey Jr. Oh my gosh. Who's your favorite Spider-Man? Tom Holland, Tobey Maguire, Garfield, Andrew Garfield. That's it. Oh, what about Miles Morales? He's really good too. They're all right answers, but Iron Man wins out because Tony Stark, I love you, 3,000 or 4,000. Garfield? Toby. You gotta go with Toby. And let's go to the winners. Here we go. Tiny Brian to announce. In third place for a $10 Amazon gift card, Soaring Yak. Make sure to email Brian, not Tiny Brian. Melodic Fox in second place for a $20. And first place, $30 Amazon gift card, Dynamic Emu. Now also, we're giving out $10 to Excited Pie. I like pie. Wait, where'd that go? Tiny Brian, away!
Tiny Brian's always here for those. I wonder how many would survive an entire class season taught by Tiny Brian. He's good for a moment. He's got a high-pitched, not a high-pitched voice, but his voice is a couple octaves above people who have higher voices. I don't know if I could listen to Tiny Brian.
What if I brought my tiny parrot?
That might be good. He brings his tiny parrot. I'm okay with that. I'll take his tiny parrot, though. Where's his tiny parrot? Tiny parrot. Where's my tiny parrot? This isn't my tiny parrot. Tiny brown parrot. Whoop, 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 whoop. There we go. Get that. I know, right? It's his tiny parrot. It's a tiny parrot, but in comparison to Tiny Brian, it's a rather large parrot. We gotta bring Tiny Brian's parrot back, though. He's where's Tiny Brian's parrot? I got so many things on here. My brain's shutting down. Not really, but where is Tiny Brian's parrot? I have it. Here it is. Tiny Brian's parrot. He's got puppet sharks. You're welcome. I'm so glad. I know my mind was a little frazzled. Had a little bit of a. Oh, there's the crazy Brian. Just hit every button. Just hit all the buttons. Just do everything. It's all madness on here. Thank you, Matt. I'm so glad people had fun. We learned a lot. Just we'll go over here. Just be on this side of the screen and just do the craziness over here. I don't even know who I am over here. Who am I? I don't even know. So this is, I think we named this version of me Brawl. It's when I misspelled my name in chat, which I can't even do. But any other last questions? People said Canvas content. Was there specific Canvas content? Let's head over to the main screen. You're welcome. I'm so glad, Chris. I hope people had fun. I hope they liked it. Discord question. Yeah, let me take a look. There, I gotta see it. This one here. Let me take a copy of it. Sure, let's do it. Let's knock out this question. You got it. Thank you, everybody. I know everyone's working really hard and keeping that positive attitude. That's what we do. And we eat dinner. This is what we do. Let's do this question. Leah, thank you. Oh, this. Yep. Oh, here we go. Let's go check this out. Oh my gosh. Thank you. Literally, I blink. We literally don't have that going on. I used to, real quick story right here. I used to just do the class publicly. And great job hiding the user on channel right there. So I used to do the class just publicly, and then I put it to unlisted streams. So my classes are in unlisted streams, but when we do these, I do them in public streams. So like, just that can happen. That hasn't happened in like years. 2 years, I think, actually. 2 years this semester. We had our last, random YouTuber thing happen. Going to the main screen. Okay, a 1992 journal article talked about people's temperatures. And the average temperature was found to be 98.2 degrees. Now, look at this curve, though. This curve is showing you what's right here. What do you see on the curve down here? I don't see the numbers. what do I see on this curve? So what do I see on this curve? What do we see? What are these? What are those? You're welcome, Mia. Thank you for being here. What do we see on the curve? The z-scores, right? So what we could do is we could go down here. Great job, Liz and Leela. Great work. And write in 98.2. And then also we could write in what next? What number would go above 98.2? So what number would go above 98.2? Like on this line right here. What number would go above 98.2? What would go above that? 98.9. And the reason is because that's one standard deviation above the mean. Now, what's interesting is we can kind of narrow down this question. Now, remember, we're trying to figure out the body temperature of the 80th percentile. If I told you 80th percentile, is that on the right or the left side of the curve? We're kind of using some logic right here to help solve this. If I say the 80th percentile, would that be on the right side, like the high side of the curve, or the low side of the curve, the 80th percentile? Is that on the right or the left side? It's on the right side. So it has to be, we could narrow it down and say the 80th percentile has to be somewhere above here. So we've already narrowed it down to this region. Some point on this is up here is the 80th percentile. What percentile is this? Like this spot right here, percentile means area below it, but we could figure out the area above it. How much is above a z-score of 1? How much area is above a z-score of 1? So let's write down here 68. This is the area between -1 and 1. So how much area is above a z-score of 1? 16. So that would make this spot right here the what percentile. I'll do a drop-down arrow. That's the what percentile. If 16% is above that, what is below it is the percentile. So what percentile would that be? It'd be the 84th percent. So wait, we're trying to find, that's the 84th percentile right there. We're trying to find the 80th percentile, right? So it's got to be a little low. Wait, this is interesting. It's showing us a point right here. And it says that this has a z-score of 0.842. Now, more importantly, this is the middle. We're going space pen. This is the middle what percent? That is the middle what percent? So between this, that is the middle what percent right there. So look at the question up here. You have to look right up there. That's the middle what percent? Well, this wouldn't be the middle 68 right here. It's close. It's middle 60, right? This is the middle 60% between the z-scores here and here. So if this is the middle 60%, then how much area is above here? So if that's the middle 60, great job right there, Leela. Great work. If that's the middle 60, then how much is above there? 20. So if there's 20% above here, then that makes this the what percentile? So we're talking about this spot. We're not talking about that one anymore. We're talking about this spot. That makes that spot right there the what percentile? So that spot, which is below it, if there's 20% above it, that makes that the 80th percentile. So somebody has a temperature of, what is this, 0.842? Is that their temperature? At this spot, which is no longer there, right here, they have a temperature of 0.842? What does that mean? What information does that tell us? That is the what of this person. That is that person's what right here. Oh my gosh, don't do that. Sorry, undo. That is that person's what right there. That would be that individual's what? It's their z-score. So that means, just interpret it right here, this person's temperature is blank blanks to the blank. This person's temperature is blank blanks to the blank. This person's temperature is blank blank to the blank. So this person's temperature is blank blank to the blank. So that's their z-score. It's not their temperature. This person's temperature is blank, so 0.842 standard deviations to where? Their temperature is 0.842 standard deviations where? 0.842 standard deviations above the mean. Does that make sense? That's what the positive z-score tells us. So let's look at this and think about it just for a second. Great job, Sam, right there. This means, but just look at it visually, the answer to this question needs to be a little bit less than what? Just think conceptually. The answer to this question needs to be a little bit less than what? Whatever we find as our answer is going to be a little bit less than this. This will help us confirm we get the right answer. So look at the screen and think the answer to this question is a little bit less than 98.9. So we know we have to be a little bit less than that because here's where we're at here. That's too high. We're going to go over here. Great job, Leela and everyone. A little bit less than 98.9 is a temperature, right? So good work right there. Good work, Matt. Good practice. And so now let's go and do it. Well, if we know their z-score, we can find their observation. Their observation will be observation equals mean plus z-score times standard deviation. So the observation is like, is it 98? I'm solving it in my head. It's like 98 point, oh my gosh, 79, I think, maybe, equals the mean of 98.2. We'll check that math here in a second. Plus, and then 0.842 times, and what am I going to times this by? We did that in yellow. What are we going to times that by? Great job, Sam. Awesome work. Tell me if I did that correctly. There's the math, and let's check it. So 0.7 times 0.842 plus 98.2, and it does round to that. 98.79. I was close. 98.7. Well, it rounds to that. So 98.79 right there when you round it. So that should do it. Or 98.8, I think, is what you might answer if you round it to one decimal. But that's got it. Trying to do it in my head right there. My brain's in like stellar space mode galaxy right now. Just like must compute decimals. But any questions? Does this make sense? This is a tougher one. I would say this is because it does a lot of concepts right here. You have to know how to read the curve. You're welcome, Leela. Thank you, Leela, for asking. Let's throw out one more 1,000 points. Remember, show up to these Kahoots for practice. Show up to office hours to ask questions. I just want to say a huge thank you to everyone who just is asking questions, because the number one thing, and that's why I try to stress to my students, is you're not here to learn this alone. Learning a class on your own is not what college is about, at least in my mind. I'm here to help, ask questions. We're going to answer all the Discord questions coming up here. We're going to answer all the emails here coming up here. Know that you can reach out. Know that there's help. Start asking. Feel free to ask questions in the general chat too. I'll be checking the general chat because I'm going to eat some food here soon. But ask questions. Just put those questions out there. Do people? I just want to hear some yeses to give me some energy right here. When people are asking questions in the YouTube chat or in the Discord chat, do you like that? Does it help you to see other classmates just throwing those questions out there and saying, here's what I'm wondering, here's what I'm looking at? Matt's like, yes. Matt, you know what? That's worth another 1,000 points. And Leela right there, and Haley. We'll make Haley a mod right here. That's what we like to see. Join in office hours tomorrow morning. Drop some questions in the chat. Gracie, Lauren, Leela, Matt, Christy, thank you so much for being here. Until tomorrow, we'll be back. Bye. You know what we're going to do? We're going to do our special ending. We didn't do it. Get ready, everyone. Here we go. Special ending to end the day. Let's do it.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No! Guys, I'm Jason. Brian's gone. I don't know. I don't know. Just go to Kahoot. We'll get this figured out. He sent you the information. It's on Canvas. It's on YouTube. Just go to Kahoot. I don't know what we're going to do, but we're going to figure this out. It's going to happen. That's all I got. Just go to Kahoot. Thanks. Ugh.